Example 9.7, page 264. Uh, a ballistic pendulum. Here we have this pendulum. Uh, it's used to measure the speed of a fast moving projectile. Okay, we have a bullet of mass m1 is fired into a large block of wood of mass m2. We have m1 and m2. m1 is fired toward m2. M1 enters inside, embeds inside M2, and M1 and M2 continues to move up together. Here we can say directly we have a inelastic or perfectly inelastic collision because M1 and M2 continues to move together. Okay, we have perfectly inelastic collision. Okay, here the question is, how can we determine the speed of the bullet from a measurement of h? So we have to find a relation between the maximum height of the system and the velocity and the speed of the bullet before the collision. So I need to calculate the relation between V1 of the bullet before the collision and the height of the system here at this point. Okay, so here we have a system, a collision at this position. After the collision, the system moves up to this point. So here we have, first of all, the collision, and second, we have a conservation of mechanical energy between the point after the collision and the maximum point. Okay, here I have to find a relation. Let's say we have M1 V1 before the collision initially. So we can say here we have inelastic collision. We can say perfect inelastic collision. In this case, we can say P just before equals to P just after. Just before we have the box with a bullet with a velocity v1, and here we have v2 equals to O. So initially we have m1 v1 plus m2 times 0 initial state. Final state, we have the box with the bullet inside. This system moves to the right at with a v final. Okay, let's say we have with vb as a final speed at this point. So finally we have m1 plus m2 times vb. Here I need to calculate v1 in function of h. As you see here, we don't have h, so we can say v1 equals to so we can calculate here vb in terms of h. Okay, and we get the final result of v1 in terms of h. How can we calculate VB? We can apply the conservation of mechanical energy between we take the system M1 plus M2. You have to precise the system M1 and M2 between the point P just after collision and the point C as the maximum position where we have H. So this one is the initial state and this one is the final state. You know, uh, between this position and this position, we don't have friction. Okay? So we have a conservation of mechanical energy. Mechanical E initial equals to mechanical E final. Initially, the system is at this point. We have the block with the bullet with a mass M. So we have a kinetic. This is the lowest level. We can say here we have the reference at this point. So we don't have kinetic. We can we have kinetic equals to M1 plus M2 over 2 with VB square. But we don't have potential at the lowest point, at this point. We don't have. Final position is here as the position C. At the maximum, we don't have velocity. So we don't have kinetic. But we have H. So we have mgh equals to m1 plus m2 times gh. Okay, we can calculate, we can eliminate m1 plus m2, m1 plus m2. We get VB equals to 2GH. So we get a relation between VB and H. We substitute its value here. We get finally V1 equals to M1 plus M2 divided by M1, and VB equals to 2GH. Okay. As you see here, for each value of V, we have a height H. So, and these values are constant. This value is constant. So here we have just a relation between the speed, the velocity of the bullet, and the height. Each time we increase the velocity here, so we get more height. It's a direct relation between the velocity of the bullet and the height of the box, the final height of the box.